So we're going to go ahead and fill out this table of values for the unit circle. And in this particular table, they haven't even written in the functions for us yet. We can do that in any order we like. I base the entire table on sine. If I know my sine values, I can get all the other values of all the other functions. In fact, I can immediately get the cosine values because sine and cosine are cofunctions, and they work backwards from each other. Knowing sine and cosine, I can use the fundamental identity to get tangent. And because tangent and cotangent are cofunctions, they will run backwards from each other. And then finally, secant and cosecant, the reciprocals of cosine and sine, are also cofunctions, and so we'll get those last of all. The radian measurements are going to be found by pretty much just dividing our degrees into 180. We know halfway around the circle is 180 degrees, and it's also pi radians. So 0 degrees would also be 0 radians. 30 degrees, 30 goes into 186 times, so we'll get pi over 6 there. 45 goes into 184 times, so we'll get pi over 4 radians for that angle measurement. 60 goes into 183 times, and finally 90 goes into 180 twice. So 1/4 rotation is 90 degrees, or pi over 2 radians. Now, how you know the sine values is completely up to you. You could build these special triangles in the first quadrant of the unit circle to get those values, looking at the opposite sides all the way along, looking at those y values. You could use some of the little tricks I've mentioned in class, like the square root over 2, and then just doing that 5 times and putting in the numbers 0 through 4 would work. Or you just memorize them. Once you've done them enough, you just come to realize that these values, 0, 1/2, root 2 over 2, root 3 over 2, and 1, give you the values of sine through those 5 angle rotations. Now remember, cosine is the cofunction of sine, and they work backwards from each other. So all you have to do is write the sine values in reverse order, and you get the cosine values. Tangent is sine over cosine. That's the fundamental identity, or one of the fundamental identities. And since I have the sine and cosine values here, I'm just going to do these divisions. 0 over 1 is 0. Root 2 over 2 divided by root 2 over 2 is 1. Anything divided by itself is 1. And 1 divided by 0 is not allowed. You are not allowed to divide by 0. So this is going to be undefined. The tricky ones are 1/2 over root 3 over 2 and root 3 over 2 over 1/2. So if we take a quick look at those, 1/2 divided by root 3 over 2 is going to become 1/2 times 2 over root 3. Once we multiply by the reciprocal of the denominator, the 2's cancel, and we end up with 1 over root 3. We can then rationalize it to get root 3 over 3. We're going to get something very similar with the pi over 3 rotation, except when we do root 3 over 2 over 1/2, and then multiply the numerator by the reciprocal of the denominator, the old algebra trick, we don't even have to rationalize. We just get root 3. And so that is those two, the only really tricky values for tangent. The good news is that once we have tangent, cotangent is exactly the same values of tangent, just in reverse order. Because they're cofunctions, we just work backwards, and we get those values. Now finally, we're going to do cosecant and secant, which are also cofunctions. Cosecant is the reciprocal of sine. They are reciprocal functions. So I'm going to go up to the sine values and take some reciprocals. The reciprocal of 0, well, that would put 0 in the denominator, which we're not allowed to do. That's an undefined value. The reciprocal of 1/2 is 2 over 1, so that one's pretty easy. And the reciprocal of 1 is 1. 1 is the only number other than -1, which is the reciprocal of itself. The only two values we have to worry about are root 2 over 2. If I take the reciprocal of root 2 over 2, it needs to be rationalized, and I get 2 root 2 over 2, which is just root 2. And finally, the last one, very similar, but not quite as nice because it doesn't reduce, would be taking the reciprocal of root 3 over 2. So we go 2 over root 3, which has to be rationalized, and I get 2 root 3 over 3, and as I said, that number, unfortunately, does not reduce. Now, the good news is secant and cosecant are cofunctions. So once again, I don't have to come up with all the values for secant. I just need to take the same ratios I got for cosecant and write them in reverse order. This is because sine and cosine ran backwards from each other. And so when I take their reciprocals, I'll get those exact values running backwards from each other. And that is the unit table completely filled out. We built the entire table from sine. So if you are going to memorize anything on this table, just memorize the sine values. If you know your trig function relationships, you can build every other value in this table just from knowing sine.